Welcome back to The Explainer. Today, we're tackling a deeply fascinating intersection of geopolitics and earth science. Honestly, it's a topic that sounds like something ripped straight out of a sci-fi movie, but it's a very real conversation happening right now. We're investigating the concept of seismic warfare. Basically, can the sheer force of human-made explosions actually trigger catastrophic natural disasters? It's a heavy question for sure, but we're going to break it down clearly and scientifically. Okay, let's dive into this. If you've been following global news at all, you've likely seen the intense, often overwhelming reports of current conflicts. Specifically, there are some really urgent questions circulating online right now regarding heavy bombardments in the Middle East, involving Iran, Israel, the Gulf states, and various Arab countries. People are looking at the massive destruction on the surface and asking a very understandable question. Can this level of intense modern warfare actually trigger massive tectonic shifts?
Section 1, Wars, Explosions, and Earthquakes.
It's just human nature to try and make sense of human-made destruction by connecting it to larger worldly forces. Right now, there are growing online anxieties drawing a straight line between current regional bombardments and the impending threat of natural disasters. A pretty prevailing rumor suggests that intense, localized bombardments might unleash some unpredictable, catastrophic wrath of nature. Basically, the fear is that dropping enough bombs is going to crack the Earth's crust and cause an earthquake. Now, we're not here to validate apocalyptic framing, but we are going to treat this as a fascinating scientific mystery. And to solve it, we're relying on hard data from the world's leading experts, the U.S. Geological Survey.
Section 2, Anatomy of a Tremor. To actually figure out if a bomb can cause an earthquake, we've got to look at the basic physics, right? We need to test this terrifying rumor with concrete science. So explosions, whether from conventional weapons or even just a standard mining blast, release all of their energy near the surface of the Earth from a highly concentrated, very small volume. Earthquakes, on the other hand, release energy from deep, deep underground, and they're generated by the gradual buildup of massive tectonic strain over huge areas. So yeah, both release tremendous energy very rapidly, which is exactly why they both shake the ground. But the physical forces at play, and crucially, the depth where they happen, are completely different beasts.
Because these forces are so vastly different, they actually look completely different to the scientists monitoring the globe. This brings us to the seismogram waveform. Think of it kind of like a fingerprint. Because a surface explosion and a deep tectonic shift create completely different vibrations, their visual records on a seismogram have totally unique signatures. Global security networks use this exact science every single day to monitor international treaties. For instance, on September 9th, 2016, a magnitude 5.3 event was recorded in North Korea. Because of the specific waveform, scientists didn't just guess it was a natural quake, they could specifically identify it as a possible nuclear explosion. The Earth literally rings differently depending on what hits it.
Section 3, the nuclear test evidence. If we want to definitively answer whether conventional bombs dropped in modern warfare can trigger regional quakes, we've got to look at the extreme cases. We need to look at the largest human-made explosions in history, underground nuclear tests, because let's face it, if anything is going to crack the tectonic plates, it would be these. The U.S. Geological Survey has actively tracked the seismic impact of massive detonations over the decades. Between 1965 and 1969, 6 major thermonuclear tests were conducted in Nevada. In 1969, they detonated the 1.1 megaton test codenamed Benham. And then, in November 1971, the U.S. conducted its largest underground thermonuclear test ever, the massive 5 megaton Cannikin test up in Yamchitka, at the western end of the Aleutian Islands.
Now, what's really interesting about this slide is the number 13. When looking at those tests, 13 is the critical number to remember. The 1969 Benham test, again, a massive 1.1 megaton nuclear explosion, did actually cause some movement on previously mapped faults, and it was followed by a sequence of small earthquakes. But here's the absolute key. Those effects were completely confined to a tiny zone extending no more than 13 kilometers from ground zero. 13 kilometers. That is an incredibly localized footprint for a megaton-level nuclear blast. Back in 1969, there was actually this massive public fear that the Nevada nuclear tests were going to trigger damaging earthquakes all the way over in California. Sounds pretty familiar to the rumors today, right? But scientists went in and plotted the times of the 6 largest Nevada thermonuclear tests against the occurrence of all Northern California earthquakes with a magnitude of 3.5 or larger. And the results? Zero correlation. Absolutely none. There were no peaks in earthquake activity at the times of those massive explosions. The historical data directly and firmly debunked the fear that distant blasts could trigger regional quakes. But we can scale this up even further to the number 5. This represents that massive 5-megaton Cannikin test from 1971. Remember, this was the absolute largest underground thermonuclear test ever conducted by the United States. Get this, the Cannikin blast released an amount of energy equivalent to a magnitude 6.9 earthquake. And where did they detonate it? In the Aleutian Islands, which is literally one of the most seismically active fault zones on the entire planet. If an explosion was ever going to be the straw that broke the camel's back and triggered a massive tectonic shift, it would be a 5-megaton nuclear weapon detonated directly inside an active fault zone. But how many tectonic quakes did it trigger? 0. Not a single one. Look, if a multi-megaton nuclear blast can't trigger a massive tectonic shift, conventional warfare bombardments absolutely certainly cannot. Section 4. Can explosions prevent quakes? To further illustrate just how vastly different human weapons are from natural Earth mechanics, let's flip the script and look at the exact reverse of our original question. If bombs don't cause them, could we use explosives to purposefully trigger small earthquakes and prevent large ones? This is actually a surprisingly common question the USGS gets. And honestly, I kind of love the way the human brain works here. People think, okay, well, if we can't accidentally cause a big one, could we purposefully set off a bunch of little bombs along a fault line to relieve the pressure and stop a big one from happening? It's a clever thought, but sadly, it's a deeply flawed scientific premise. According to the USGS, using explosives to prevent quakes is physically impossible for a few key reasons. First, as we literally just learned from the nuclear data, even huge amounts of explosives almost never cause even small earthquakes. Second, the math just doesn't work out. It would take hundreds of thousands of small earthquakes to release the energy equal to just one large one. Third, and talk about human hubris here, if this actually worked, we'd have absolutely zero control over the size of the earthquake we just created. And finally, small and large earthquakes start out in the exact same way deep underground. We possess a total, literal inability to manipulate massive tectonic stress. We just aren't that powerful. Section 5, the final scientific verdict. So, taking all of this historical data, the seismic waveform monitoring, and the basic laws of physical energy, we can apply it right back to that pressing geopolitical question we started with. So, the crucial point is summarized perfectly by the U.S. Geological Survey. The range of a possible earthquake triggered by an explosion is limited to a few tens of kilometers from the shot point. The science is definitive, it's thoroughly tested, and honestly, it should be highly calming. We can firmly put this anxiety-driven myth to rest. The intense, tragic bombardments happening in the Middle East, or anywhere else on the globe for that matter, cannot summon some impending wrath of nature. Yes, an explosion can cause incredibly localized, tiny aftershocks that are smaller than the blast itself, completely restricted to a few miles. But conventional bombings absolutely cannot reach deep into the Earth's crust to trigger large, distant tectonic shifts. As we wrap up this explainer, I really want to leave you with this thought to ponder. Humanity has engineered weapons capable of immense surface devastation. We can certainly shake the ground we walk on, but when we actually look at the raw data, are we vastly overestimating our own destructive power compared to the deep, uncontrollable, and ancient forces of the Earth itself? It's a pretty humbling reality to realize that no matter how loud our conflicts get up here on the surface, the deep mechanics of the planet remain entirely indifferent to us. Thank you so much for joining me for this focused look at the science behind the headlines. Keep questioning, keep learning, and I'll see you in the next explainer.